Hi, welcome to David Howe's Unit 4 mid-assignment. In this video, we'll be going over 3 questions. So starting with question 1, we'll be finding the trigonometric equation for this graph below in question 1 right here. And we could choose to use a sine equation or a cosine equation. For my case, I am using a sine equation. In order to find this equation, you need to find all the values in the a value, the k value, the d value, and the c value. So first, I found the amplitude by subtracting the max value to the minimum value, and then dividing it by 2, which I got 22.5, which is also the a value. Next, I found the axis, which is adding the maximum value to the minimum value and then dividing it by 2. I got y equals 1.5, which is also the c value. Based on one whole cycle of the graph, which is 12 months, I have determined that the period of the graph is 12. Plugging it to the equation, I found the k value, which is pi over 6. In order to make the graph a sine equation, I must phase shift 3 units to the right, giving me a d value of 3. Next, with all 4 values, I plugged it into the equation, which gives me f at x equals 22.5 times sin over bracket pi divided by 6 bracket x minus 3 close bracket minus 1.5. So this is my conclusion. Next, on to question 2. For part A, as you can see, I've graphed the motion of a Ferris wheel based on its height versus time, as you can see here. For part B, I need to find the trig equation of the graph. I once again use the sine equation. Again, with the help of min and max, I was able to determine the amplitude, which is 5, and the axis as well, which is 6, which is my corresponding a and c value. Using the period, which is 24, I found the k value, which is pi over 12. And lastly, to make the graph a sine equation, I phase shift the graph 6 units right, making the d value 6. With all the 4 values, I plug it in the equation, and I got f at x equals 5 times sine times bracket pi divided by 12 times x minus 6 close bracket plus 6. And here's my conclusion. For part C, by plugging in 12 into the equation as x, you can check the accuracy of the equation. When you plug in the x coordinate 12, the y coordinate, which is f at x, should be equal to 11, which is the highest point on the graph. Right here, the maximum point, 12 at 11. This checks the accuracy of a graph because by plugging in the x value of a point on the graph into the equation to check if it equals to the y value, it checks if the point is accurately there or not. Other good points to check with are 0 at 1 or 24 at 1, as these are all obvious points on the graph. Lastly, to question 3. For part A and B, you have to again find the trig equation, this time with the cos equation. With the given min and max value, you can find the amplitude and axis, which is the a and c value. To find the period, it's kind of tricky. You need to subtract the 2 in between times and then convert it into hours. Because from the highest point to lowest point is always half a period, you have to then multiply by 2 to get the full period. Once again, plug the period into the equation and you get the x value, which is pi over 6.22. Because we need our graph to be a cosine equation, we must start the equation at the highest point, which is 822. We have to convert it into hours and then move that much to the right, making the d value 8.35. Plugging in the 4 values, we'll get h at t equals 6.4 times cos times pi divided by 6.22 times bracket x minus 8.35 close bracket plus 10.9. Continuing to part C, we need to determine the height of the wave at 11:30. First, we need to convert the time into hours, which is 11:50. Then we plug it in to the equation we just found. And we end up with 10 meters, 10.8 meters. This is my conclusion. The height of the tide at 11:30 is 10.8 meters. Next, in part D, it asks us to use a graphical approach to find the time where the height of the water is above 12 meters. By looking at the graph, we can see it is approximately between 5.58 to 11.11. Convert it into hours and you have 5:35 to 11:07. With the graph, we can roughly guess that the time that is available to dock is 5:35 to 11:07. That's everything that I'll be covering today. Thank you for watching my video.